In this last video on a review about trigonometry, we will just complete the angles in the unit circle. So we are taking the second special triangle. Just as a reminder, if you are struggling to remember how to get this triangle, think about the triangle with all the sides equal to 2 and then just divide it here on two angles. This is going to be 90 degrees. This is going to be 60 degrees, or pi over 3. When you divide pi over 3 by 2, you get the angle pi over 6. When you divide this side by 2, you get the side 1. And then this one you can use the Pythagoras theorem to evaluate it. You'll get the side square root of 3, right? Square root of 4 minus 1. That's 4 minus 1 is 3, so square root of 3. Okay. Now I want to put this similarly to what we did with pi over 4, 90 degrees triangle. We want to put this triangle in the unit circle, so we'll rescale it such that the hypotenuse is going to be 1. So divide all the sides by 2, and this triangle becomes 1/2, 3 over 2. Now I'll use this triangle twice in the unit circle. So once I'm just gonna put the unit circle like this, the triangle like this in the unit circle. So there it is. Hypotenuse 1. This here is going to be the side. This point is 1/2. So this side here, the distance is 1/2, and this distance here is going to be square root of 3 over 2. So I get the point 1/2 square root of 3 over 2. And then if I rotate this triangle, so basically if I do this, so if I just flip this triangle here, it's going to be pi over 6. This is 2. This is square root of 3 over 2, 1/2, and pi over 3. And then so it's the same triangle, just flipped. And then if I put this triangle in the unit circle, I will get this triangle right here. So pi over 6. This distance here is going to be square root of 3 over 2. That means that the x coordinate is going to be square root of 3 over 2. And the y coordinate here is going to be 1/2. So this one is going to be 1/2. Okay, so as a reminder, I'm telling you that in the unit circle, sine of theta is being read by just reading the y values of the points on the unit circle. So for example, from what we have here, sine of pi over 6, so you find pi over 6 and you find this point here, the y coordinate is going to be 1/2, right? So that means sine of pi over 6 is 1/2. Sine of pi over 3, this is pi over 3. The sine value is being read when you look at the y coordinate, square root of 3 over 2. Similarly, cosine of pi over 6. Cosine of pi over 6 is square root of 3 over 2. And sine of pi over 6, cosine of pi over 6 is equal to 1/2. But now having these values, okay, you can determine all the values of the trigonometric functions evaluated at the angles that are multiples of pi over 6 and pi over 3. For example, if I translate this point right here, okay, by symmetry, what will I have? Well, this point, the y coordinate is going to stay the same, so that's 1/2, right? As you can see, stays the same. The x coordinate, though, is just going to be negative square root of 3 over 2. Okay, then what is this angle? This angle here is pi over 6. But as you remember from the previous video, this is the angle that we are looking for. Okay, so what is this angle such that cosine of that angle is negative square root of 3 over 2 and sine of that angle is 1/2? Well, that angle is pi minus pi over 6, or that's 5 pi over 6. Similarly, if by symmetry you reflect this point on this side, again in this quadrant the y values stay the same, so that's square root of 3 over 2. and the x values are just getting the minus sign in front of them, negative 1/2. Okay, this angle on the other hand so this angle would be what? If this is pi over 3, that means this is pi over 3. So pi minus pi over 3 is 2 pi over 3. 2 pi over 3. Okay? And then you can do this for all the other angles. Okay, so you can translate this point here, and you will obtain the values. As you remember, in this quadrant, x and y values are negative. That means that sine and cosine of all the angles in this quadrant between pi and 3 pi over 2 are going to be negative. That's negative square root of 3 over 2 and negative 1/2. And the coordinates of this point are negative 1/2 and negative square root of 3 over 2. Okay, so this angle that starts from here is going to be pi plus pi over 6, that's 7 pi over 6, and this angle right here is pi plus pi over 3, and that's 4 pi over 3. So this angle all the way to here is 4 pi over 3. And then if you translate them here, as a matter of fact, doesn't matter, you can start from here. This point will have coordinates in this quadrant. X is positive, that's right, and y is negative. That means that sine of this angle in this quadrant is positive and the cosine of the angles in this quadrant are negative. And here I have 1/2 and a square root of 3, negative square root of 3 over 2. Okay, this angle here would be 2 pi minus pi over 6, which is 11 pi over 6. So this angle all the way to here, it's 11 pi over 6. And this angle is 2 pi minus pi over 3. That's 6 minus 1 is 5 pi over 3. So this angle all the way to here, it's 5 pi over 3. And this one is 11 pi over 6. Okay, so let us do a few problems with these angles. For example, evaluate how much is sine of 3 pi over 2. Well, 3 pi over 2 is this point right here. So if this is pi over 2, 2 pi over 2, 3 pi over 2, the coordinates of this point are 0, my bad, 0 and negative 1, right? So sine of 3 pi over 2, you read the y coordinate, right? So that's negative 1. By the same logic, cosine of 3 pi over 2, well, is the same angle, it's this angle all the way to here, 270 degrees. If you're looking for cosine of that angle, you just read the x coordinate, so that's 0. Okay. The next question is, how much is sine of 7 pi over 6? Well, 7 pi over 6 is right here, right? 7 pi over 6 is this angle. Okay. And you're looking for sine of 7 pi over 6. Obviously that coordinate is negative 1/2. That is negative 1/2. cosine of 7 pi over 4, well, 7 pi over 4 is equal to 8 pi over 4 minus pi over 4. So basically you're trying to find where this angle is. 8 pi over 4 is 2 pi minus pi over 4, which is equal to, which is 7 pi over 4. So where that angle would be, so that's 2 pi full circle minus pi over 4. It's right here. Do you know these coordinates by heart? Well, if you don't know them, that's fine, because you know, and you have to know, these coordinates by heart, the coordinates of sine and cosine of pi over 4. So that's square root of 2 over 2 and square root of 2 over 2. By symmetry, when you're going to translate them here, then obviously the x coordinate is still positive, so square root of 2 over 2, and this one becomes negative square root of 2 over 2. Now our question is what? How much is cosine of 7 pi over 4? Okay, cosine of 7 pi over 4. This is our angle, 7 pi over 4. And cosine of 7 pi over 4 obviously is square root of 2 over 2. Okay. Next question is sine of 5 pi over 3. So where is 5 pi over 3? 5 pi over 3 is equal to 6 pi over 3. So minus pi over 3, which is 2 pi minus pi over 3. Okay. So let's see where that angle is. So that's 2 pi full circle minus pi over 3 right here. If you don't know, and nobody expects you to know these coordinates by heart, always have, what did I say? These 3 pairs of coordinates in the first quadrant you have to know. So if this is pi over 3, then you know that the coordinates are 1/2 and square root of 3 over 2. Then these coordinates by symmetry are going to be 1/2 and negative square root of 3 over 2. Now what is the question? The question was how much is sine of 5 pi over 3? You look at the y coordinate, that's negative square root of 3 over 2. Next question is cosine of 11 pi over 6. So we do the same thing. 11 pi over 6 is equal to 12 pi over 6 minus pi over 6, which is 2 pi minus pi over 6. So we do this just to locate, just to set up the angle, okay? So that's full circle minus pi over 6 right here, right? So this is our angle that we're looking. This is 11 pi over 6. Okay, so how to remember these points? Well, always know that there is a symmetry between these points, between this point and this point. This point you have to know by heart. That's the point with square root of 3 over 2 and 1/2. Then this point here will be also square root of 3 over 2 because x stays positive, and negative 1/2. And now we're looking for cosine of that value, of that angle. The cosine of that angle gives me square root of 3 over 2. Cosine of 4 pi over 6. So now let's just locate the angle first. 4 pi over 6 is equal to pi. Well, you can actually simplify this. This is going to 2 pi over 3, which is pi minus pi over 3, right? And where is this angle? So that's pi 180 degrees minus pi over 3. So it is this angle right here. This is 4 pi over 6 or 2 pi over 3. Okay, and this point is symmetrical to the point square root 1/2, sorry, and square root of 3 over 2. So that means that this point has coordinates negative 1/2 and square root of 3 over 2. Now we're looking for the cosine value of that. So the cosine value is being read at the x coordinate, so that's negative 1/2. Four pi over 3 on the other hand, so that's 4 pi over 3 for this value is equal to pi plus pi over 3. Pi plus pi over 3 is 4 pi over 3, so that's pi plus pi over 3 is this value right here. This point is symmetrical to this point. So if this point had coordinates -1/2 and square root of 3 over 2, then this point here, what did I say? In the third quadrant, all the points are negative, so -1/2 and negative square root of 3 over 2. Okay? So the question is, how much is sine of 4 pi over 3? Well, that's negative square root of 3 over 2. And so on and so on. For example, 10 pi over 6, cosine of 10 pi over 6. You can simplify this as 5 pi over, right, if you divide by 2, 5 pi over 3. So that's 6 pi over 3 minus pi over 3. That's 2 pi minus pi over 3. Okay, so that's a full circle, 2 pi minus pi over 3, this point right here. And then you can look at the previous example to check how we get the point here, 1/2 negative square root of 3 over 2. We're looking for cosine of that value, so the cosine is going to be positive 1/2. Okay? If we are looking for tangent of pi, okay, so that's 180 degrees. Tangent of pi is equal to sine of pi over cosine of pi. In the unit circle, this is the angle pi, okay, and it has coordinates -1 and 0. So sine of pi is the y coordinate 0 over cosine of pi is the x coordinate -1, that's 0. Cotangent of 6 pi over 4. Okay, so cotangent of 6 pi over 4 is cosine of 6 pi over 4 over sine of 6 pi over 4. So let's locate 6 pi over 4. 6 pi over 4, you divide it by 2, this is going to equal to 3 pi over 2. Well, 3 pi over 2 is right here, is this point, right? 3 pi over 2 with coordinates 0 and -1. So this is the ratio between 0 and -1, which is 0. Sine of 5 pi over 3. We already did this one. This is a mistake, so negative square root of 3 over 2. Tangent of 11 pi over 6. That's sine of 11 pi over 6 over cosine of 11 pi over 6. Now you can look how we got the value here. This is this. We're going to use that unit circle. So this is -1/2 over square root of 3 over 2. And if you simplify this, this is -1 over square root of 3 or negative square root of 3 over 3, and so on and so on. Cotangent of 5 pi over 3 is going to be equal to cosine of 5 pi over 3 over sine of 5 pi over 3, and that's equal to 1/2 over negative square root of 3 over 2, which is negative square root of 3 over 3. And this is how we use the unit circle to evaluate these trigonometric functions. Now we will do a few more limits. As theta goes to 0, tangent of theta is 0, sine of theta is 0, so the numerator goes to 0 and the denominator goes to 0. So when the numerator and the denominator go to 0, I'm trying to apply this sine of theta over theta limit, the one that goes to 0. One thing that we can do here is split this into two limits, tangent of theta over 3 theta minus limit of sine of theta over 3 theta. Conveniently, theta here goes to 0, so this limit right away, sine of theta over theta, will approach to 1. Okay, so the second limit just becomes 1/3. And the first limit here can be written as sine of theta over cosine of theta over 3 theta minus 1/3 that's left from here, which is equal to the limit of sine of theta over 3 theta cosine of theta as theta goes to 0. So this one here is approaches to 1 minus 1/3. So I get 1 over 3 times cosine of 0 is 1. So 1/3 minus 1/3, that's equal to 0. The second limit, tangent of pi over 4. Well, now evaluate tangent of pi over 4. That's sine of pi over 4 over cosine of pi over 4. And if you remember, sine of pi over 4 and cosine of pi over 4 is the same value. So that means that tangent of pi over 4 is square root of 2 over 2 over square root of 2 over 2, and that's just 1. So I get 1 minus 1, which is 0. The numerator approaches to 0, but the denominator stays away from 0. This ratio is just 0. Okay. In the next limit, again, I have 0 over 0 limit. 0 times 1 is 0, tangent of 0 is 0, over 4 times sine of 0 is 0. So here again I can split this up. So it's x cosine of theta over 4 times sine of theta plus limit of tangent of theta over 4 times sine of theta. Here this limit, as theta goes to 0, this ratio theta over sine of theta goes to 1. Okay, and then you can use direct substitution. Cosine of 0 is 1 over 4 plus the limit tangent of theta is sine of theta over cosine of theta over 4 plus times sine of theta. Here sine of theta cancels out, so we have 1 over 4 times plus the limit of 1 over 4 times cosine theta. As theta goes to 0, this is 1, so 1/4 plus 1/4, that's equal to 1/2. In the next problem, the numerator approaches to, by direct substitution, sine of pi over 4 is square root of 2 over 2. And then I already said that tangent of tangent of pi over 4 is 1, so 1 minus 1, this thing goes to 0. So right away we know that this ratio is going to result in going to infinity. Okay, the only question is now whether it's going to be positive or negative. Well, that's going to depend on the ratio between the numerator and the denominator. The numerator is positive. Now we just have to determine whether the denominator is positive or not, or negative. That will depend whether tangent of theta is greater or less than 1 as theta approaches to pi over 4 from the right. Now in the unit circle this might be slightly confusing, what is right and what is left, so I'm going to restate that as theta approaches to pi over 4 from the side where the angles are bigger. So basically we're approaching theta here shrinks towards pi over 4. Okay, in here sine of theta is greater than cosine of theta. Sine of theta is greater than cosine of theta. For all the angles between pi over 4 and pi over 2, sine of theta is greater than cosine of theta. That means that tangent of theta is going to approach 1, but from the side, from the right side, from the side where the numbers are greater than 1. So 1 minus something greater than 1, that's negative. Positive divided by negative is negative infinity. Okay, so again I'm going to repeat how I got this. The question is whether this difference is approaches to 0 from the left or from the right, which basically boils down to the question whether tangent of theta approaches to 1 from the left or from the right. Well, let's see. As theta approaches to pi over 4 from the angles that are bigger than pi over 4. Okay, In here, all the values are of sine are greater than the values of cosine. Okay, so that means that the ratio of sine of theta over cosine of theta is going to be very close to 1, but slightly bigger, because these values, the numerator is greater than the denominator. So that means that I'm going to approach 1 from the right. So 1 minus something that is bigger than 1, it's negative, and that's how I get negative infinity. Okay, so here tangent of 2 pi over 3. Okay, so how much is tangent of 2 pi over 3? 2 pi over 3 is right here. Okay, this point has coordinates negative 1/2 and square root of 3 over 2. So that means that tangent of 2 pi over 3 is negative 1/2 over square root of 3 over 2, which is negative square root of 3 over 3. The numerator goes to negative square root of 3 over 3. The denominator, on the other hand, right, goes to 4 plus 4 times negative 1/2, because cosine of 2 pi over 3, I can read how much it is here, which is 4 plus 2, which is equal to 6. So this limit is negative square root of 3 over 3 over 6, and that's negative square root of 3 over 18. You see direct substitution. Wow, sorry about that. You see the direct substitution here works perfectly fine. Okay, I plugged 2 pi over 3 for tangent, I got negative square root of 3 over 3. I plugged 2 pi over 3 for theta. Cosine of 2 pi over 3 is negative 1/2. So 4 plus 4 times negative 1/2, it's 6, and that ratio gives me negative square root of 3 over 18. We have similar limit here. So again, theta goes to 2 pi over 3 from the left now. Okay, by direct substitution, we already evaluated this is negative square root of 3 over 3. But now this one here is 2 plus 4 times cosine of 2 pi over 3 is negative 1/2. So that's equal to 2 minus 2, and that's equal to 0. Okay, so what do we have here? The numerator goes to a constant different than 0, the denominator goes to 0, so that means that the ratio is going to be infinity. Now the question is whether, because the numerator is negative, that's obvious. Now the question is whether the denominator is positive or negative, whether it's when theta goes to 2 pi over 3 from the left, whether this sum is positive or negative. Definitely it's going to go to 0, but whether from the left or from the right. Okay, so that will depend on what? That will depend on whether this 2 times cosine of theta is going to be less or greater than negative 2, right? So let's see. As we're approaching, so let's make this angle a bit bigger. Okay, we are approaching 2 pi over 3 from the side where theta is less than 2 pi over 3. That means from this side we're approaching. Okay, here still sine of theta in absolute value is greater than cosine of theta. And is that going to help me somehow? No, sorry. So here, okay, where do we read the cosine values? We read the cosine values on the x-axis. As the angles here are approaching 2 pi over 3, we can see that the cosine values of these angles are approaching negative 1/2 from the right. Okay, so now you have negative 1/2, and now you're multiplying from the and all the values are between negative 1/2 and 0. So negative 1/2, 0, and now you multiply these values by all of these values. You multiply them by 4. This is going to bring you to negative 2, but also from this side, right? Okay, that means that all of these values are approaching to negative 2 from the right, negative 2. Okay, so 2 plus negative 2 that approaches from the right. So basically any point here plus 2 is going to be very close to 0, but less than 0, because, for example, take this is negative 1.999. Plus 2 is going to be very close to 0, but positive, which means that this is going to be positive. And the negative divided by positive is negative infinity. And the last problem, I have cosecant of theta. Just recall that cosecant of theta is equal to 1 over sine of theta, and evaluated at 11 pi over 6, this angle here is 11 pi over 6. So how much is sine of theta? 11. That angle is 11 pi over 6, and these values are square root of 3 over 2 and negative 1/2. Okay, so this is going to be equal to negative 2, which is the reciprocal of negative 1/2. So the numerator goes to negative 2, and the denominator here goes to, well, we just said that sine of 11 pi over 6 is negative 1/2. 10 times negative 1/2 plus 5 is equal to 0. So I have constant different than 0 divided by something that approaches to 0. This inevitably is going to be infinity. Okay, so again, similarly as in the previous example, here the numerator is negative. The question is what is going to be the denominator. Okay, so that means now this limit as it is written would not exist, so let's choose a side. Let's now say from the right. Okay, let's approach this value from the points where values of the angle that are greater than 11 pi over 6. Okay, so that means that I'm approaching 11 pi over 6. So this angle right here is 11 pi over 6. And I'm approaching for all the angles here. Okay, so these angles are opening like this, and as you can see, if this is negative 1/2, these angles are going to be between 0 and negative 1/2. So I have these values, negative 1/2 and 0, and they're approaching from this side. They're here, they're approaching negative 1/2 from the right. When I multiply them by 10, they're gonna land at negative 5, but here, right, a little bit bigger than negative 5. Okay, that means 10 sine of theta plus 5 basically is going to be something between negative 5 and 0 plus 5, that is going to be positive. You see, these values here are going to be 10 times sine of theta, as theta approaches to 11 pi over 6 from the right. Okay, so all of these values plus 5 are going to be close to 0, right? But they're going to be positive. So negative divided by positive is